Okay, here we go again. 6-4. This is called arithmetic series. And if you remember, all a series is it's a sequence that we put plus signs in. So we're basically just going to add a sequence. And when we see that word arithmetic, we know that from one term to the next we are going to be continuously adding the same number, or we could be continuously subtracting the same number. Just a couple other definition type things. Series are often an S is used, so a defined series will be defined using an S. So you can get used to that notation. And if you see something like this, S sub n, and n is usually going to be a number, what that means is what is called the nth partial sum. And really what that means, that might sound a little weird, is the sum of the first n terms. And we're going to do an example to hopefully make this make a little more sense. So let's take a look at a series. So 20, 25, 30, 35, 40, 45. So that's a sequence, but when I put plus signs in between here, I now find myself with what we call a series. So if somebody asked me to figure out what the sum of the first 6 terms of that series is, the notation I would use would be an S little 6. So there's 1, 2, 3, 4, 5, 6 terms. Now I want to go ahead and go through a process so that I can actually get an equation, because this one we could just add up. It's only 6 terms. But if someone said, hey, take a look at this series and tell me what the sum of the first 100 terms is, that's a little messier. So come along for the ride here. I'm going to work my way into an equation, which in the end you just need to know the equation, but it might help you to see where the equation comes from. So I'm going to do something else, and hopefully you're going to agree that I'm allowed to do this. So instead I'm going to say S sub 6, I could also write it as 45 plus 40 plus 35 plus 30 plus 25 plus 20. Now why would I want to do that? Well, these really are 2 equations, so if I wanted to I could add them up. So I'm going to do that right now. So if I have an S sub 6 and an S sub 6 and add them, I get 2 S sub 6's. And now this is where something interesting is about to happen. When I take a 20 and a 45, I get a 60. When I take a 25, whoops, I meant to say a 65. Let me fix that. 20 and 45, I get a 65. 25 and 40, I get a 65. 30 and 35, I get a 65. And notice what happens all the way across. So I notice I get a bunch of 65s here, so I'm going to, rather than writing it as a bunch of 65s added, I'm going to use multiplication. So I really have 6 65s. And so if I want to figure out what the sum is, one thing I could do is I could say, well, I'm just going to maybe divide this 2 out. I'll divide the 2 out over here. Give myself a little more board space here. And it turns out that the sum of the first 6 terms then is really just 3. If I think about this, 6 times 2 times 65. And if you multiply 3 times 65 out, you get 195. So we would say this partial sum, S sub 6, is 195. Now, the thing that's interesting about this is that we can actually work ourselves into an equation, and I think I'm going to use this right here as the place to see the equation, where I can say that S sub n is really equal to whatever n is. If you notice, I have a 6 here, and my 6 has found its way over here, divided by 2, and I'm going to just multiply that by what I get when I add this 20 and this 45. And the interesting thing about this, which will be true for any one of these series, is that the 20 is the first term and the 45 is the term that's in the position of how far I want to go. So really I'm just going to multiply n over 2 times what I get when I add up the first term and the nth term, which corresponds to this n. So this is helpful when we're trying to add things up, especially if there's a whole bunch of terms and we don't want to have to add them all. Now I have good news for you, and you should have this sheet. This is really our first journey into the reference sheet that you're going to get from the old Albany people when you take your Regents. Now there's a bunch of stuff on this sheet that we are not yet ready to deal with, but there is something on this sheet which I just showed you, and that is this right here. So that right there is the sum of a finite arithmetic series. Now you'll notice they wrote it differently than the way I wrote it, but if I rewrote it, I could write the way I wrote. N over 2 times a sub 1 plus a sub n. So here's good news. Good news is they give you this, so for any test on this chapter, I will also give you this equation. Okay, so let's continue with this a little bit. So to be clear then, for any arithmetic series, with n terms, I'm just going to write this again, this sort of help getting this in your brain. S sub n is equal to n over 2 times the sum of the first and the last term. Now, sometimes you're going to know what that first and last term are, and other times you won't. So I do want to remind you that this term, a sub n, we have an equation for, and that is the following. A sub 1 plus n minus 1 times the common difference. So if I wanted to write this, if I was in a situation that I didn't know what was the nth term, I could write this equation a little bit differently, where I would write n over 2 times, I have an a sub 1 and another a sub 1, so that would be 2 a sub 1 plus n minus 1 times the common difference. Now, I would not memorize this, but just be aware, because in the end you could always just use this little piece to figure out what that nth term is. And we're going to do an example to hopefully help you get there. Okay. So, example. Write the sum of the first 15 terms of 1 plus 4 plus 7 plus dot 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 in sigma notation. Okay, so this is similar to what I did in the last video, so it's good review. So how do I do that? Well, as I said before, for me, if you want me to write in sigma notation, I might get my counter started, and if there's going to be 15 terms, then I'm going to go from n equals 1 to 15. So now I just need an equation, and I'm going to come over here and I'm going to write out my little standard form, which either you get it because you understand it, or you're going to have to memorize that. So the first term is 1. And remember, in order to put this in that sigma notation, I need to leave that n, because that's the thing that this machine needs to change the integers into. And now I just need my common difference. So if I come back here and just say 4 minus 1, oh yeah, I'm adding 3. 7 minus 4, oh yeah, I'm adding 3. So I see that my common difference is 3. And I'm just going to clean this up. I'll put that 3 out there. And I get 1 plus, a little distributing, 3n minus 3. And so this turns out to be 3n. I have a 1 minus 3, that would be a minus 2. So I'm going to come over here and drop this down. 3n minus 2. Okay, so now I'm going to extend this problem a little, and I'm going to say find the sum of the first 15 terms. So from before, you could use your fancy calculator and get your calculator to find that sum, but that's not what today's theme is. So today what I want to do then is figure out the sum using the equation that we just learned. So if you recall then, and this equation is on your sheet also, I'm going to use this equation, n over 2 times a sub 1 plus a sub 15. So the number of terms then is going to be 15 over 2 times a sub 1. So I need to know what is the first term, which I see right here is a 1, plus I need to know what the 15th term is. So either I can work this equation in right here, or I can come to the side of my paper, which is what I'm going to do right now, and figure out what is the 15th term. So the 15th term then is equal to 3 times 15 minus 2. 40 minus 2, also known as 43. So 15 over 2 times 1 plus 43. You can do this in your calc if you want. So this would be 44. And in the end, we should end up with 330. Okay, one last example. The sum of the first and last term of an arithmetic sequence is 80. And the sum of all the terms is 1200. How many terms are there? Okay, so once again, this is just kind of recognizing problems in words. So if this is June and you hadn't seen this in a while, you might say, yeah, some arithmetic sequence. And if I could just plant the seed now, we need to start remembering that when we see words like that, maybe there's something on the sheet. Yes, there's lots of other stuff on the sheet, but if you look here, right on our sheet, there's an equation that has a lot of this stuff in it. So I'm going to use the equation this time in the form they write it on our sheet, just so you can see it's really no different. So we are told that S sub n is equal to n times a sub 1 plus a sub 2 all over 2. And let's just see if there's some information that we could plug in. So the sum in the first of last term of an arithmetic sequence is 80. So I know that the sum, I'm just going to write S sub n again, is equal to 80. The sum of all the terms is equal, I take that back. I take that back. Delete. Okay, I take that back, because the sum of all the terms then is 1200. And that is equal to, I don't know how many terms there are, times the sum of the first and last term. So that is where I want to say, and this should be an a sub n, I apologize. Okay, so the sum of the first and last term, that was part of the problem, I'd written a 2 there, is 80. And then this needs to be divided by 2. So hopefully you're with me. Okay, so now notice that the only thing that I don't know, if I just look at this equation here, is the n. And so this should allow me to solve this and figure out my answer. So 1200 then is equal to 80 divided by 2 is 40n. And when I take 1200 and divide it by 40, I get n is equal to 30. Okay, so that's it. Once again, just to be clear up here from my miswriting and speaking, S sub n from the sheet is equal to n times a sub 1, that's the first term, plus the last term. So this is the first and the last term, divided by 2, and that's why this goes here, because that is the sum of the first and last term, and then this 1200 is the sum of all the terms. That is all.